value of n is, you have to find out n. Will you solve this numerical on your own, or you want me to explain this? You will solve? Okay. Next question. You will solve on your own? Okay, it's very similar to that. You will have to find out n. They are not given n. Okay. So, okay, n you have to find out. Exit state to the ground state. So, same thing, but only thing is you have to find out n, right? So, n1 1 anta ತಗೊಂತೀರಾ, n2 9 ಮಾಡ್ತೀರಾ, n ಅಂತ ತಗೊಂತೀರಾ. n2 no, you have to take it as n. Is 16th question. The electron in the hydrogen atom jumps from, last sal ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? 15th question ನೀವೇ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಂತೀರಲ್ವಾ? ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ನ n ಅಂತ ತಗೊಂತೀರಾ, n2 ನ n ಅಂತ ತಗೊಳ್ಳಿ, ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ನ 1 ಅಂತ ತಗೋಬೇಕು. n1 is 1, n2 is n. Find out n. Okay, next one. The electron in the hydrogen atom jumps from excited state, that is n is equal to 3, to its ground state, and the photons thus emitted irradiate a photosensitive material. If the work function of the metal is 5.1 electron volt, the stopping potential estimated to be. Can you quickly solve this? Can you quickly solve this? Okay. Now, so basically energy En is minus 13.6 by n squared. Now E3, third excited state, n is equal to 3, jumps from excited state, n is 3, minus 13.6 by 9, which is minus 1.91, okay. So left with 4, 1.51, minus 1.51 electron volt, correct? That is the excited state, and E1 is minus 13.6. So therefore E3 minus E1, E3 minus E1 is minus 13.6, sorry, minus 1.5 minus of minus 13.6, correct now? Yavaglo aste you have to subtract like this only, right? E3 minus E1, E3 is minus 1.1 minus of minus 13.6, which is minus 1.1 plus 13.6, 12.1 electron volt. So E3 is this, sorry, E3 minus E1, 12.1 electron volt. So stopping potential, so the total energy is this. As per this equation, total energy is 12.1 electron volt, correct na? H naught is how much? 5.1 electron volt plus EV naught. Okay, so therefore V naught is equal to 12.1 minus 5.1, correct na? 7 electron volt, 7 volt. Okay, 7 volt. ಯಾಕಂದ್ರೆ EV naught ಇಲ್ಲಿ ಎಲ್ಲ ಕಡೆ E ಇರೋದನ್ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದ್ದೀನಿ. So therefore 12.1 volt, 5.1 volt, and this becomes EV naught ಬಂದು V naught ಆಗುತ್ತೆ. So therefore V naught is equal to 12.1 minus 5.1, which is 7 volt, right? Option number D. ಆಯ್ತಾ ಇದು? Okay, next question. The Bohr model of atoms. So which option is correct? The Bohr model of atoms. Option A or B or C or D? Option A, right now? So assumes the angular momentum of the electron is quantized. So angular momentum mvr is equal to nh by 2 pi. So angular momentum is quantized. So as per Bohr's postulate, so therefore option 1 is correct. Uses Einstein's photoelectric equation, that is wrong. Predicts continuous emission spectra, that is also wrong. Predicts the same emission spectra, that is also wrong. Okay. Next, the lifespan of atomic hydrogen, fraction of 1 second. So basically 0.3 seconds. The lifespan of atomic hydrogen is, okay, So therefore 0.3 seconds. Next one, 19th question. In the Bohr model of hydrogen atom, the centripetal force is furnished by the Coulomb attraction between the proton and electron. If A0 is the radius of the ground state of orbit, m is the mass and E is the charge of the electron, and is in the vacuum permittivity, the speed of the electron. So we know this equation, mv squared by r is equal to E squared by A0, correct now? E squared by A0. So therefore velocity, okay, here it is A0, correct now? So here it is A0 squared, correct? Centripetal force mv squared by r, so radius is given as A0. So mv squared by A0 is equal to 1 by 4 pi epsilon naught E squared. So this is the given charge of the proton and electron. Hydrogen atom, so it has one proton, hydrogen atom, one electron, therefore E squared, the force is E squared. Distance between the proton and electron is A0 squared, radius. So this gets cancelled. So we want V squared is equal to 1 by 4 pi epsilon naught E0 squared by A0, okay, by m is that. So therefore which is E squared by square root E squared by 4 pi epsilon naught, okay, they have given option A0 m, okay. So E by root of 4 pi epsilon naught A0 m. Okay, this we wouldn't have taught you in the board part alli ellu bandirodilla, but you have to use your understanding of physics. We have to equate this. Centripetal force is equal to the electrostatic force between the electron and proton, that you have to equate and arrive at. Many questions will be like that, okay. So that's the reason you have to understand the concept understanding is more important than other solving numericals. Okay, next question. Twentieth question. Okay, so if an electron in a hydrogen atom jumps from the third orbit to the second orbit, it emits a photon of wavelength lambda. So when it jumps from fourth orbit to third orbit, the corresponding wavelength of the photon, okay. So we know wavelength of the photon 1 by lambda na, r into 1 by n1 square minus 1 by n2 square. So first one is third to second orbit, 3 and 2. So n2 is 3 and n1 is 2, right. So this is the first one. So ratio of or I call it as lambda 1, 1 by n1 square is 2 squared, 1 by 3 squared, so which is r 1 by lambda 1, okay, 1 by 4 minus 1 by 9. 1 by lambda 1 is equal to r into 36 by 5. This we have solved, I think, no? So therefore lambda 1 is equal to 36 by 5 into 1 by r, correct? Correct? So second one is what? 4 to 3. 4 to 3, right? Fourth orbit to third orbit, jumps from fourth orbit to third orbit, correct? So therefore it is 1 by lambda 2, which is r into 1 by 3 squared minus 1 by 4 squared. So which is lambda 2 or 9 into 36 na LCM, 9 into 36, 6 minus 9, correct? Correct? So 9 into 36 is how much? Sorry, 9 into 16. 1 by lambda 2 or into, okay, which is 7 by 144. Correct now? Therefore lambda 2 is 144 divided by 7 into 1 by r. Are you clear? So the ratio of this, what are the ratios of this? Lambda 1 by lambda 2. Lambda 1 by lambda 2 is 36 by 5 into 1 by r by 144 by 7, 1 by r. R gets cancelled. 7 goes to numerator na. 7 by 5. Okay, this is 36 36 ones or 36 fours, I think. Correct now? Is it correct? No, no. Sorry, sorry. This will be 12. 3, I think. 12 ones are 12 twos are. Correct now? Okay. So therefore, what we get, it is 3 by 12. Correct now? Okay. 3 ones are 3 fours are. So 7 by 20. Huh? They've asked for lambda 2 by lambda 1, is it? Okay. When it jumps from fourth orbit, the corresponding wavelength of the photon. Okay. What is the corresponding wavelength? Okay. So here it is lambda 1 by lambda 2. So therefore, if I take this as lambda and this is lambda 2, so 7 by 20. Therefore, lambda 2 is equal to 20 by 7 lambda. Option number C. Question number 21. 21st question. Hydrogen atom in its ground state is excited by a monochromatic radiation of lambda is 975 angstrom units. Okay. So the number of spectral lines in the resulting spectrum emitted will be. So hydrogen atom is in the ground state is excited by a monochromatic radiation of lambda 975 angstrom units. Number of spectral lines in the resulting spectrum. See here, when it jumps from one state to the other state. So when electron jumps from one state to the other state, you know that this state is a temporary state, correct? So it will come back, correct now? When it comes back to the ground state, so when it gets excited, it absorbs energy, and when it returns to the ground state, it emits energy. Ardhada? So that energy has how many spectral lines, right? But here they are not specified what is the state, n anta helilla. So we have to find out. So what is the energy corresponding to 975 angstrom units? Ardhada? So basically ಏನು ಮಾಡಬೇಕು ಅಂದರೆ ಇದು this basically, so this is basically E2 minus, I'll take it as En2 minus En1 is equal to minus 13.6 1 by 1 square, this one right, minus 1 by n square, correct? This is little lengthy. So now this energy is given by Hc by lambda. Hc by lambda minus 13.6 into 1 by 1 minus 1 by n squared. Will you solve on your own? It takes some time. Okay, take it as homework. I'll just tell you how it is to be done. Okay, so right. So ಇದು ಬಂದ ಮೇಲೆ ನಿಮಗೆ n ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ ಇಲ್ಲಿ. ಅರ್ಥ ಹೇಳಿದ್ದು? So you get first state is, this is the energy state. Now H value you know this, H is 6.625 10 to the power minus 34, C is 3 into 10 to the power 8, lambda they have given 975 angstrom units. So adana meters convert ಮಾಡ್ಕೊಳ್ಳಿ into 10 to the power minus 10 meters. Find out the value of n, right? And number of spectral lines is given by, if you get the n, the number of spectral lines is given by n into n minus 1 by 2. ಅರ್ಥದ? So number of spectral lines, if I know the n value, the number of spectral lines is given by n into n minus 1 by 2. Are you clear? Right. In hydrogen atom, first jumps from third excited state to second excited state. So electron in hydrogen atom first jumps from third state to second state. Jumps from first third excited state to second excited state, and then from second excited state to first excited state. So second excited state is how much? What is the value of n? Second excited state is 3. right? This will be what? 4 na, correct na? Artha telidu? So an electron in a hydrogen atom first jumps from third excited state. Third excited state means n is equal to 4. It's not state 3. Third excited state. So n is 4 to second excited state. Second excited state is n is 3. Then from second excited state is n is equal to 2 to the first excited state. First excited state is tappaitala. Wait. First one is, listen, 1 second. First jumps from third excited state. Third excited state is 4 to second excited state. That's all. This is not it. Okay. Arda, this one is there. So it from here and from here. Artha telidu? So electron in a hydrogen atom first jumps from third excited state. Third excited state is n is equal to 4 to the second excited state, n is equal to 3. And then from second excited state, that is n is equal to 3 to the first excited state, right? The ratio of wavelengths. What are the ratios of wavelengths? Right. So ratio of wavelengths is 1 by lambda. First we'll find out this. So R into, okay, 1 by 3 square minus 1 by 4 square. Correct na? Artha idaitu? Understood? So because formula is 1 by R, we have this equation n1 square, n2 square. So therefore 1 by lambda I call as 1 R into 1 by n1 square. N1 square is what? 3 square. First yavuttu n1 is togobekalva. Correct? N1 is this 3 square minus 1 by 4 square. So therefore R into 1 by lambda 1. So 1 by 9 minus 1 by 16. I think we have already done this. Okay. So it is 144 by 7 alva. Correct. This is lambda 1 aitu. Lambda 2 enagate? Lambda 2 is R into 1 by 2 square minus 1 by 3 square. So which is 1 by lambda 2 R into 1 by 4 minus 1 by 9, which is 5 by 36. Same problem with ya? Oh, okay. Same question, huh? Okay. So answer is 20 by 7. I think first question, 20th question alva? Same, okay, 20th and 22nd. ಅಲ್ಲಿ ಏನಾಗಿದೆ lambda ಅಂತ ಹೇಳಿದ್ದಾರೆ. Okay. So question different. Okay, right. So option number D. Okay. Okay, next question is 23rd question. Question number 23rd. Electron of a stationary hydrogen atom passes from the fifth energy level to the ground energy level. So electron of a stationary hydrogen atom passes from the fifth energy level to the ground level. The velocity that the atom acquired as a result of photon emission. Okay. So we have to find out first, when it emits, what is the wavelength? Ardada. So there are two things here. So we have to find out the wavelength. So when you have to find out velocity, so we have to use de Broglie concept. De Broglie concept. So first find out lambda. 1 by lambda is equal to R into energy find out madkobeku minus 13.6 into, correct? Or else you can find out energy bekagilla. This is R into 1 by n1 squared minus 1 by n2 squared. Right. 1 by lambda, R value is not given, na? R is there. Okay, you can retain that R. So R into, so from where to where? fifth energy level to the ground state. So therefore it is 1 by 1 minus 1 by 5 squared. Fifth energy level, correct. So therefore it is R into 1 by 1 minus 1 by 25. So it is lambda. So 1 by lambda is equal to R into 25, 24. That barilla. So therefore lambda is equal to 25 by 24 into 1 by R. 1 by R alva. Right. Now we have to find out the velocity. So as per de Broglie's, h by mv. Correct now? H by p or h by mv. Correct? So therefore v is equal to h by m lambda. So therefore h by m lambda is how much? 25, 24 into 1 by 25 by 24, 1 by r. Correct now? So therefore it goes to, so hr 24 hr by 25 m. So option E, 24 hr by 25 m. We can need not solve it. 24th question. The transition from the state n is equal to 3 to n is equal to 1 state. So any series which is to the n is equal to 1 state, what type of series it's called? Lyman series. So any transition from a higher energy state to the first state is called Lyman series, right? So that is Lyman series, but n is equal to 3 to 1 state is Lyman series. Ultraviolet radiation, infrared radiation will be obtained from transition. So you know Lyman series lies in UV region, right? Balmer series visible, correct now? Infrared remaining, all three, passion, near infrared, middle infrared and far infrared. So all these three series lies in, okay, so infrared region. So therefore from 4 to 3, correct now? 2 to 1 is Lyman series, 3 to 2 is Balmer series, 4 to 2 is also Balmer series, and 4 to 3 is passion series. So therefore 4 to 3 is question. Very simple question, but only thing is you need to know concepts. If you are thorough with the concepts, you can directly answer this question. It's a mains question. Mains question, mains, J mains question. J mains question. So some questions are from mains, but not all questions will be like this. But some questions will be very easy, but only thing is you need to know concept, right? Okay. Next one. ಆಯ್ತಾ ಇದು ಅದು ಕ್ವಶನ್ ಅರ್ಥ ಆಯ್ತಾ ನಿಮಗೆ ಅರ್ಥ ಆಯ್ತಾ ಅದು ಓಕೆ 24th question next 25th question question number 25 ionization potential of hydrogen atom is 13.6 electron volt. What is meant by ionization potential? Are you still writing that backside? Okay, right, listen here. What is meant by ionization potential? Infinity state. Ionization means to liberate the electron from ground state to the infinite state, means to remove the electron completely from the atom. That's called ionization potential required, and the corresponding energy is called ionization energy. So they have given ionization energy 13.6 electron volt for hydrogen atom, for electron in hydrogen atom. Now hydrogen atoms in the ground state are excited by monochromatic radiation of photon of energy 12.1 electron volt. According to Bohr's theory, the spectral lines emitted by hydrogen atom will be. So if you see the difference, right? So what is the state of that 12.1 electron volt is, right? What state is that? Ground state to excited state, 12.1 electron volt. Ground state are excited by monochromatic radiation of photon of energy 12.1 electron volt. Artha teliddu? 12.1 electron volt is required to excite the electron from ground state to the a particular state, right? So now the number of spectral lines emitted by the hydrogen atom. So it is ground state is minus 13.6 na, right? ಅರ್ಥ ಆಯ್ತಾ ಹೇಳಿದ್ದು? ಸರಿ, 12.1 minus of minus, ಕರೆಕ್ಟಾ? ದಿಸ್ ಇಸ್ minus 12.1, 13.6 ಎಷ್ಟಾಗುತ್ತದು? 1.5 1.5. ಸೊ 1.5 electron volt ಯಾವ ಸ್ಟೇಟ್ ಎನರ್ಜಿ ಸ್ಟೇಟ್ ಅದು? ಇದು ಥರ್ಡ್ ಆರ್ ಫೋರ್ತ್? minus 13.6 ಡಿವೈಡ್ ಬೈ ಥರ್ಡ್ ಅಂದರೆ ಎಷ್ಟಾಗುತ್ತೆ? n ಸ್ಕ್ವೇರ್ ಅಲ್ವಾ? 9 ಆಗುತ್ತೆ, ಕರೆಕ್ಟಾ? 9 ones are 4 left, 5, correct. 1 point electron, right? So therefore the state of the system is 3. So I have already told you number of spectral lines is n into n minus 1 by 2, which is n into 3 minus 1 by 2. So 6 into 2 divided by 2, which is 6, correct? Sorry, 3 spectral lines. 3, option number C. Are you clear? Are you clear? ಅರ್ಥ ಆಯ್ತಾ?